Today we're covering Chapter 8, Lesson 6, Volume of Prisms. And a prism is a three-dimensional figure with at least two parallel, congruent faces. For example, this face right here on the bottom is parallel to this face up here on the top. So the top and bottom are parallel to each other. They're also congruent. They're the same size. Volume is the measure of space a 3D figure occupies. So think of it's how many cubes would fit inside something. And the formula that we use for that is volume equals capital letter B times lowercase h. And it works for any type of prism. And that capital letter B stands for area of the base. B means area of the base. So we have to calculate the area of the base. For example, we might find the area of this and then multiply it times the height. And probably in nickels, you might have learned that formula, length times width times height. But that doesn't work for prisms like this. So let's try an example of finding the volume of a triangular prism. Start with the formula. That's always what guides us. So the volume equals area of the base times the height. And when there's a capital letter, that means we have to plug in some other formula. Since the base is shaped like a triangle, we plug in the formula for a triangle, which is base times height divided by 2. Still multiplied times the height of the prism. Don't get the height of the prism confused with the height of that triangle right there. Now let's plug in the numbers that go for those letters. So the base of the triangle is 3.5 and the height of the triangle is 2, all divided by 2, times the height of the prism, which is 4.2. Okay, and then we want to simplify if we can. So there's a 2 on bottom and a 2 on top, so I can simplify that, which leaves me with just 3.5 times 4.2. Which equals 14.70 or 14.7. And volume is a measurement of how many cubes fit inside it. So this is feet cubed or cubic feet. Let's look at some of the problems that you're going to do by yourself. You're just finding the volume of each one of these different shapes. Let's talk about number 4 here. Volume is still area of the base times the height. And the base of this shape is a rectangle. So the formula for a rectangle is base times height times the height of the prism. So the base measurements are 1.1 times 1.5. And then the height of the prism is 2.6. So the answer is 4.29, I'm dropping the last 0, millimeters cubed, because volume is the amount of cubes that fit inside the box. Okay, let's look at number 6. Again, we start with the formula, which is volume equals area of the base times the height. And I need to plug in a different formula for the capital letter. So the shape of this base is a triangle. That means I'm going to plug in the formula for a triangle, which is base times height divided by 2 times the height of the prism. Okay, the base of the triangle is 2.6 times the height of the triangle, which is 4.1, all divided by 2 times the height of the prism, which is 5.1. Since there's really nothing you can simplify easily, we're just going to work it straight across. 2.6 times 4.1, and then I'm going to get an answer and divide by 2. So the answer is 27.183 meters cubed, because volume is the measurement of how many cubes are fit in it. Let's look at number 7 now. Number 7 says the United States Post Office has 2 different priority mail flat rate boxes. Which box has the greater volume? So you will need to multiply the measurements for each box and see which one is greater. You can change those to decimals, or you can leave them as fractions.